Hi, I'm Brock Crana.
I'm Andrew Pierce.
And I'm Jack Wolf, and our senior project is the Ice Scratcher Boat.
The Ice Scratcher boat consists of an 8 to 10 foot aluminum john boat, a structural steel frame, and a drive system. A 5 horsepower Briggs & Stratton engine will be used to power the boat, and the whole assembly will be propelled over large bodies of ice with help from a studded wheel or saw lift. The purpose of the Ice Scratcher boat is to provide a safer, faster, more efficient, and more fun way to travel across frozen bodies of water. Using the Ice Scratcher boat would drastically reduce slip and fall injuries. And for ice fishermen, the time from dock to fishing spot would decrease when compared to traveling by foot. The Ice Scratcher boat is a better and more secure way of transporting fishing equipment to and from your favorite fishing hole. And traveling swiftly across ice in a boat seems a lot more fun than traveling by foot. The most common type of fishing injury, ice fishing injury, is an orthopedic musculoskeletal injury. Orthopedic musculoskeletal injuries affect the muscles, nerves, tendons, joints, and cartilage in your limbs, neck, and back. These soft tissue injuries are caused by sudden or sustained exposure to repetitive motion, force, vibrations, and awkward body positions. Those who ice fish are at risk of developing an orthopedic musculoskeletal injury every time they slip and fall on the ice, or every time they carry a large amount of equipment to and from their favorite fishing hole. By developing the Ice Scratcher boat, our group can help reduce the amount of injuries sustained during these winter months. Show a quick video here demonstrating the Ice Scratcher boat. So here is what our project will be based off of: a structural steel frame with a varying sized boat laid atop, a drive system on its own structural steel frame, moved side by side and propelled with a lever and a saw blade to move it across the ice swiftly.
So, at Alfred State, we have been taught a wide range of information over our years here. With this project, we want to be able to use this information to help us design and complete this project. We want to show off everything we have learned here, and at Alfred State, they always talk about how hands-on learning is the cornerstone of their culture, and we will be able to do that with this project. So our first 2 semesters here, we were exposed to graphics CAD and solid modeling. In graphics CAD, we used AutoCAD software, and solid modeling, we used the SolidWorks software. We learned how to properly create working industrial drawings, which include the detail drawings and assembly drawings, and the bill of materials that go with them. We've learned the alphabet of lines, so your visible lines, hidden lines, center lines, and dimensioning techniques to help us graphically communicate these drawings to people all over the world. We learned how to call out fasteners as well as welds on our drawings, and we learned how to make 3D models into 2D working industrial drawings for fabrication. Manufacturing processes, we learned measuring techniques. The tools that go with them are calipers and micrometers. We learned how to apply tolerances, so general and specific tolerancing. We learned how materials like plates, shafts, flat bar, and angle iron are called out on a parts list and on drawings. The most important topic from this class that we learned that will be applied is welding. We learned about stick welding, which is shielded metal arc welding, gas metal arc welding, which is MIG welding, and gas tungsten arc welding, which is TIG. And for our project, we will be using MIG welding to weld our tubing for our frame together. In mechanical design principles, we were taught a wide variety of machine design topics. For our project, the most relevant topics are belt drive systems, which covered sizing and selection of components, the traction mechanics, which solve for the tension in the belt, which will make the drive system run, and we were taught about belt life, which shows how long this belt will last. We were also introduced to chain drive systems, which also cover the sizing and the selection of components, chain life, and chain fatigue. We also learned about torque transfer devices, which included shafts and keyways. And for our drive system, we will be using all of these items listed here. Mechanical systems design explored bearing design and selection. For our project, we will have bearings, most likely pillow block bearings, to support our shafts on our drive system. Column design was also used to determine how much weight that our frame could hold and if it'll buckle or not. We went over how to size welds for certain applications, which we will do for our frame. And mechanical fasteners for our project will be analyzed for sizing to see how big they need to be and if thread stripping will occur under certain loading. One final thing that we looked at and that we're going to try to incorporate in our project are springs. We learned about compression, tension, and torsion springs. And we want to be able to use springs as sort of a suspension system for where our drive wheel and drive system attaches to the boat. And in senior seminar and project design, we completed our research papers, which give us sort of a better understanding of how we can improve our project and insight into new ideas and how we can apply those to our project. And we also created a Gantt chart, which is basically the schedule for our project, which covers the fall semester and the spring semester, and that ultimately helped with the organization of our project.
This semester, our group applied for and successfully received $650 via a grant from Alfred State College to begin working on the ice scratcher boat. And as a group, we will reapply for more funding in the spring 2019 semester. A majority of the materials that have already been purchased during this fall 2018 semester were purchased with the $650 grant provided for us by Alfred State College. The 2x2 by 14 gauge structural steel tubing was purchased from State Line Supply Company. The sealant, primer, and paint supplies were bought from Granger Industrial Supply. And most of the tools that we'll be using during the fabrication of this project, like grinders, saws, welders, and hand tools, will be borrowed from Alfred State College. The drive system components that still need to be purchased include, but are not limited to, sheaves, belts, sprockets, chains, and shafts. Sheet metal for belt and chain guards will be purchased from State Line Supply Company.
So there were many considerations we had to think about when designing our frame. One was we wanted the boat to be able to be removed from the frame so that it can not only be used during the winter but all seasons. Also, so a different boat could possibly be put in its place. It will also make the frame much lighter and easier to transport. We decided to make the front of the frame angled, as you can see down there. This is so that it can climb over uneven surfaces much easier than if we had a flat fronted frame. The frame will be two separate pieces. As you can see over there, the main frame and the engine and drive system frame will be separate and bolted together. This will allow for the engine mount and drive frame to be able to pivot back and forth, much like a normal boat motor, so that the boat can be steered by the operator. The material that we decided to go with was, as Brock said earlier, 2x2x14 gauge square tubing. We might change the material for our engine and drive system frame to make it a little bit lighter, but that'll come on later. Also, Jack mentioned springs, and we will try to incorporate springs in as sort of a dampening technique when the drive wheel hits any uneven surfaces. The frame will be built using a MIG welder, and the two separate frame pieces will be bolted together, as I said earlier. The engine that we will be using is a 5 horsepower Briggs & Stratton engine. It will need to be slightly modified so that we can have a variable throttle, and to vary this throttle we will have a twist throttle so that the operator can easily change the speed of the boat as they're moving across the ice. So for our drive system, on the engine we will have a centrifugal clutch, as you can see there. This will run a belt to a second sheave on a jack shaft behind the engine, and this jack shaft will transfer the power to a sprocket across on the other side of the frame, and then that sprocket will be driving a chain down to the final sprocket on the drive shaft, which will run our drive wheel. We will take careful consideration into how much torque is needed at the drive wheel to move the boat across the ice, and we will size our sheaves and sprockets accordingly. But we hope to not sacrifice speed for torque, because we would like this to be much faster than walking. To move our ice scratcher across the ice, we will have a spiked drive wheel that runs along the ice that is powered by our engine and drive system. The spikes will dig into the ice and propel the ice scratcher forward. This is really our biggest hurdle in the project because we are not quite sure yet what we're going to use for a drive wheel, but we have a few ideas, such as utilizing the CNC machine to make a spiked wheel, or possibly having a metal disc with spiked points welded to the outer edge. And we plan on having our drive wheel about 12 inches in diameter.
So in conclusion, the classes and education we receive from Alfred State will aid with this project.
Materials selected by us will be funded from the college.
Our hands-on work will create a frame and drive system.
And the final product will be able to propel across ice safely and efficiently.